Hi, today we're going to discuss paradoxes. And I always found paradoxes extremely interesting. And this video is based significantly on Golden Lescott Back, which is an excellent book which I recommend everyone should read and reread. If you feel that GEB is perhaps too heavy for light reading, I strongly suggest skipping everything which you don't want to read. It's a huge fat book and you're going to get something out of it. Especially nowadays, there is a lot of talk about AI. We have so many things like Chat GPT, which are really, uh, they're really changing the world in some ways. And so it's important to know perhaps the foundational uh, principles of intelligence and how it works and what is identity, those kind of things. So these are very interesting questions have which I think as a for a lay person to read, I think it's the best book, introduction book. I say this as a lay person. Uh, but yeah, I mean, what? Okay, so uh, what are paradoxes? Paradoxes are a set of statements where taken to their logical conclusion, they lead to a very absurd outcome. I won't say they're completely, uh, they're not always contradictions because the mathematical paradoxes are usually just unintuitive because they deal with things which, in a way, which we don't normally experience in day to day life. So let's have one of those paradoxes first. It's called Hilbert's Grand Hotel, and as you can see in this drawing, it's basically no vacancy, but we can move some people around. I like that line a lot, and that's what the problem is. There is a Grand Hotel, and it's always full, but you can always get more room. You just move everybody one room to the next room, and the person at the entrance gets the first room, and the hotel magically expands to fit everybody. So this obviously all the people who live in this hotel think this is. I mean, all the people who hear about this hotel think it's a pretty neat idea, so they want to visit. So there's a train which brings the people to the hotel, and it's infinitely long. There are an infinite number of bogies, and in each bogie there are an infinite number of people. So how do you fit all these people into the hotel, right? And at face value, it doesn't really make sense. There are infinite bogies with infinite people, and there's just an infinite hotel here. I mean, how does it work, right? So the reason it works is because infinity doesn't work how we think it is, right? It's not like it's not a number. Like you can't count up to it. It's not a really big number. It's infinity. So in this situation, the solution which many people think of is prime number rooms can't be prime numbers and their powers can't be repeated, right? So prime number and the rooms are the rooms which you allot to each coach. So the first coach is 2 power uh, the powers of 2. So the first passenger goes to 2, the second goes to 4, and so on and so forth. The next coach goes to the powers of 3, and so on after that. And since the prime numbers can never really run out, you will eventually fit everybody inside the hotel. Uh, yeah, and the interesting thing about this problem is it can be expanded in so many ways. In the prime number solution, a lot of the hotel is going empty. But there are solutions where you can fill each and every room of the hotel and still have everybody get into a room. There's also like you can raise the level of infinity. For example, instead of one train, there's infinite trains. Okay, at and then at the infinite station, I guess. And then instead of having one infinite station, you have an infinite number of infinite stations, and so on and so forth. So long as you are able to count the number of levels of infinity, um, you can fit everybody inside the infinite hotel. The only time when the infinite hotel breaks is when there are infinite level of infinities, and that's because this is actually just an elaborate way to teach you about how natural numbers and rational numbers work, and I encourage you to look that up. It's pretty interesting how it is proven that there can't be a set which is bigger than the natural numbers and yet smaller than the rational numbers. It's been proven to be like that, I think. So I found that extremely interesting. And now we'll go to the next paradox. And actually, you may think that the way I'm listing the paradoxes is a bit random, but you'll see what I'm coming at the end. So this paradox is a bit of the opposite. Okay. This paradox is about Zeno's paradox of Achilles and the tortoise, where Zeno says that you can never actually move, that any distance which you see is actually infinite. And the way he proves it is, he says that, say you have Achilles, who was an incredibly fast runner, I assume, and a tortoise. And the tortoise gets a bit of a head start, and Achilles' job is to just catch the tortoise. So now when Achilles runs to where the tortoise was before, the tortoise has moved a little bit ahead. And then when Achilles runs to that point, the tortoise has moved a little bit ahead, and so on and so forth, such that he can never actually catch it. So what Zeno is saying is that since this distance can be divided into an infinite number of steps, and we cannot actually cover infinity, hence motion is impossible. We cannot cover an infinite amount of distance, and every distance can be divided into an infinite amount of parts. So that's the thing. And the reason I call this the opposite of Hilbert's paradox is that over there you were trying to like count up to infinity, like you were like infinity is like a normal number, so we could probably do that. It probably won't work. But here it's like he says it's already infinite, and that's why you can't do it. But we actually can in practice. Okay, and that's what the argument called solvitur ambulando came out, because the philosopher Diogenes, in response to this question, simply got up and walked away. I mean, other thing leaves without elaboration meme, right? What he means is that, yeah, I mean, you can say it's infinite and I can't actually go, but I'm actually able to walk and cover the distance. So I think your paradox is not really correct. Okay, and so that's the thing. And the third paradox which I wanted to talk about was the Epimenides paradox, which is the liar paradox. And he is famous because he was a Cretan, like from the Crete, the Minotaurs and stuff. So he was from Crete, and he gave the statement, all Cretans are liars. So let's just look at this diagram, which is the a revised version of his paradox, and it says this statement is false. And when you say this statement is false, you might think, okay, if this, then that. So let's just simplify it a bit more, okay? Because I just want to comment a bit about the nature of the this in this. So we'll just look at this next slide, which is the exact same thing, but in two sentences, okay? And it says the first sentence is the next statement is true, and the sentence after that is the previous statement is false. So let's just start going in the loop, right? Like the arrow show. So let's just say the next statement is true. Okay, fine. The next statement is true. So then we go to the next statement and it says the previous statement is false. Okay, so we go to the previous statement and say the next statement is true. Obviously that's false. So it means the next statement is false. And then when we come back to this thing, it says the previous statement is false. And if that is false, then we're right back to the next statement is true. So you cannot actually decide what is going on here. You cannot decide whether anything is true or false, and that is the special thing about this statement is false thing. It is actually creating a kind of infinite loop. Okay, you can keep going on. It's not so obvious in this statement because we don't naturally associate the word this to be infinite in nature when referring to itself. So when we point to something and say this, yes, it's just one step, right? But when you refer to a statement itself, it becomes an infinite circular kind of thing, and that's what this diagram shows. So now what I want to say is that all these paradoxes, they have something common among them, and that thing is they have a component of infinity in them. And it just seems that humans can't really understand infinity. Okay, so in the Hilbert's paradox, but that is a more well-known paradox these days, so it's not a big deal. If there are other lesser known paradoxes, like if you put an infinite amount of balls and take out one out of every 10 for each of them, then in 1 hour you can have 0 balls in the thing. Okay, so long as you take a fixed amount of time to take out the balls, in 1 hour there will be 0 balls, even though you put in an infinite amount of balls. So these are very, very unintuitive things because we just don't grasp infinity that well. Similarly, for Zeno's paradox, if we have to think about the infinity, we can't actually deal with it. And that's the same thing which I feel is expressed in this statement as well. I mean, the next paradox as well, that this statement is false, the liar paradox. And that is, there is an infinity hidden in the statement this. I mean, in the word this. And that infinity is what is causing us issues with understanding the meaning of that sentence. We just, just what we have done is we just wrapped it in a box and said, this is a paradox. I can't handle it. I can't deal with it. I cannot, keep going in a loop like this. So I've just boxed it over there and kept it over there. I don't want, it's a paradox. That's all. That's the opinion. So I think that whenever the human brain can't deal with infinity, so when it comes up with infinity, that's when you automatically get a paradox. So I think that's an interesting insight about paradoxes, that there is something hidden. I don't say it's my insight. I got this insight after reading other people's work, especially Hofstadter's book, Dr. Hofstadter's book. So the infinity is really what we call a paradox. Okay. And now, the reason for I actually made this video was I saw in some video like, why isn't God real? Because of that omnipotent paradox, which I'll just, omnipotent God paradox, which I'll just mention in the next slide. So the omnipotent God paradox is that if God is omnipotent, he can lift any rock. Okay. And if he's omnipotent, he can create a rock so big, I mean, so heavy that nobody can lift it. Okay. And people say that it's not possible for both to exist simultaneously at the same time. I guess it's a logical paradox, so it doesn't work. Now, I don't say I believe in God. I'm not, that fond of the whole divine stuff. I do think that God is a bit of a, he's like a placeholder for things we can't understand, much like what a paradox is, right? It's like there's infinity over there and we can't handle it, so we just say, okay, that's a paradox. And same thing, we can't handle some other infinity and we say, okay, that's God. But let's just take this thought experiment, and here's the this thing. Here's the paradox, like God struggling to lift up the rock or something like that. And I just want to I see two ways of dealing with this. All right. So the first way of dealing this is just like some trivial, joke solution, like, okay, fine, God's like Chuck Norris. Instead of, pushing the rock up, he just pushes everything down, something like that. So yeah, that's one really easy solution. But I felt it was better to just, get the infinity out of the paradox. So let's just look at this slide where it says, God can lift anything as the first statement, and this rock can't be lifted. So if you see it, I'm not saying it's as convincing as the previous liar paradox one, because that is just so elegant. But it does seem to me that this kind of is an infinite loop, just like that one. Okay, because if you say, okay, God can lift anything, so this rock has to be lifted, then you check the rock, this rock can't be lifted, okay, then God can't lift anything, no, God can't lift anything. that kind of thing. Okay, so I think that if you did have an omnipotent God, he'd be able to deal with that kind of thing by just like doing some infinite stuff. Like God, if a God is infinite, he can just simultaneously infinitely be not lifting the rock and lifting the rock at the same time. Something like I don't know. It's just don't take this as a. It's not like scientific or anything. It's not even probably not even correct, and there's probably a lot of contradictions within the thing. But this is just like my rough intuition that this is not really an argument to be used against omnipotent God, and I know lots of people just use it because maybe they found it out when they were like teenagers or something, and actually I found it out later, and I thought it was a pretty cool argument for some time. uh, like but it's not really right. It's like there's issues with it. Okay, and I wouldn't want to. It's interesting to be able to like take it apart. Okay, the paradox that just because a god is omnipotent doesn't mean that he can't lift his own rock or not lift it or whatever. Okay, so I think that an omnipotent god could possibly resolve that paradox. Okay, and anyway, so moving on to this thing, now that we are on the subject of God, and because this is heavily inspired by Gold Kebab, I just wanted to discuss the concept of how paradoxes are just like, it's they're based on logic. Like if you follow a logic, you get a paradox. And logic seems to be a way to express an infinite amount of things in one or two sentences. So just like the liar paradox, when we are saying this statement or that statement or something like that, we are actually invoking a certain infinity which is not revealed until we put it in a paradox. Okay, so for example, the example given in Gold Kebab is like, say there's a number called prime. There's a number which is prime, 5 for example. If 5 is prime, normally we just say it can't be divided by 5. I mean, it can only be divided by 5 and 1 to get a proper division. So, but the reality is, if you divide 5 by any other number and there are infinite number, other set of numbers, you will not get a correct answer. Like you won't get a whole number. And really, we are encapsulating that infinity of divisions by just saying, yeah, 5 is prime. And similarly, we do a lot of this thing. We do a lot of it in logic in our day-to-day speech. And in Gold Kebab, there was a interesting passage. Like there's a sequence of chapters about Zen, and apparently Zen is about showing that this infinity exists, and when you can break out of the thing of collapsing that infinity into thing, that's what is probably an enlightenment. I'm not an expert on Zen, and this is not even what Douglas Hofstadter has said. I guess this is what I felt on reading it. So let's just see that last thing. Okay, this is a koan or whatever, which is a problem question that when you keep thinking about it, it doesn't make any sense, but apparently if you keep thinking, you could break through and reach the true knowledge. I mean, not the true knowledge, even in the chapter itself, it's like there is no limit to the enlightenment of Zen, because there is a passage where somebody asks, is there anything after enlightenment? And the and the teacher says it is there, but it is not mind, not things, and not Buddha, which basically means that it can be described and it's definitely there, but it's not something of these things. Okay, so and I would recommend you read this book because it's such a dense thing to say, and he's done such a good job of saying it that anything which I say is not actually as good. But okay, fine. Let's see this go on. Okay, so it says Shuzan held out his short staff and said, "If you call this a short staff, you oppose its reality. If you do not call it a short staff, you ignore the fact. Now, what do you wish to call this?" And the commentary on it is, If you call this a short stuff, you oppose its reality. If you do not call it a short stuff, you ignore a fact. It cannot be expressed with word, and it cannot be expressed without words. Now, quickly say what it is. So, what they're trying to say is that if you say it's a short stuff, you're encapsulating the stick to this thing. But if you don't say that if you say it's not a stick, then that's a lie. It is a stick, but it's also so much more than a stick, and that thing is what he's trying. I guess I don't know. I can't tell for sure because these guys are on another level, but that is the thing which they're trying to show, that it is there, that infinity, and we are just collapsing it in our brain, because we just want to use the stick for something and move on with our life, but it's there if you just go and see it. So that's, I want to end on that note by saying that paradoxes are a way of, if you get a paradox, you should keep it. Like, it is something which you should think about. I know it's something which is very hard to think about, and it's very, it's not possible to say to like fully think about it, but by just the action of thinking of it will change your thinking and change your life in some way. You will maybe just like Hilbert's paradox, you will learn something about infinity itself. Maybe like in Zeno's paradox, you would say that just because I think something is like this doesn't mean that it is like that in reality, and you would have to like kind of find a way to fit reality to your thinking or the other way around. And in the third example of the liar paradox, you would realize that so much we take for granted, communication and meaning, all this is just built on sand, and it's just like there's an infinite amount of knowledge which we are just trying to somehow tell people using words. And I think that's something which is amazing. I think that humans are like, we know that we are specks in an infinite universe, and we just manage to deal with it somehow. And then, we work, we live our lives, we eat food and all that kind of thing. And at the same time, all this is also going on, and we're aware of it. We're aware of it in one way, and we're also not, and we kind of are also not aware of it in another way. And yeah, I think that's what paradoxes are all about. It's about, bringing infinity into your everyday life, and just showing you that, hey, it's out there, and you can have it in your life. Like, I don't say like, it's not like some religious thing or whatever, but you can experience that thing just by thinking about these things. And I think everybody should find a paradox and which they like, and spend some time really paradoxing. Okay, thank you, have a nice day. Like and subscribe or whatever. There are not going to be any likes. This is the first video. Okay.